Corporate planning often starts with a deceptively simple question: how much revenue will we generate next year? To answer it, analysts look backward. This chart illustrates a basic sales forecast. Analysts draw a regression line through historical data, extending average growth into future years. But linear projections assume a static environment, ignoring real-world variables like inflation and changes in pricing. Because these dynamic variables constantly bend the trajectory, a backward-looking forecast is incomplete. To build an actionable corporate strategy, that initial forecast must be transformed into a detailed sales budget. The sales budget, sometimes called the revenue budget, serves as the quantitative starting point for the entire annual master profit plan. Moving from a forecast to a budget requires abandoning abstract trend lines and establishing precise expectations for both unit sales and dollar revenues. Setting projections requires measuring price elasticity. As a product's price increases, its unit volume decreases. In a complex catalog, this expands into cross-product elasticity. Changing one price creates ripple effects, altering the sales volume of entirely different products. We can observe exactly how this behaves using a multi-product budgeting scenario. To accurately project total corporate revenue, an analyst must mathematically map these cross-product interactions before finalizing the budget. This table outlines a company's sales budget for the coming year, featuring 3 product lines. Before any pricing changes, their combined sales generate a total revenue of $20,500,000. The primary product, Item 1, moves 200,000 units at $50 each. Item 2 moves 150,000 units at $10. And Item 3 moves 300,000 units at $30. Management is considering a pricing shift. They propose a 10% price increase on Item 1, which historical data indicates will cause its sales volume to decline by 20%. We must systematically recalculate the entire master budget based on the consequences of this single 10% price hike. First, we adjust the baseline for Item 1. Applying the 10% increase to the original $50 price yields a new unit price of $55. Next, we factor in the elasticity. The 20% volume penalty drops the expected sales down to 160,000 units. Multiplying the remaining units by the new price produces a revised revenue of $8,800,000. This is a direct reduction from Item 1's original baseline revenue of $10 million. Because consumer demand for this product is highly elastic, the aggressive price hike actually triggered a net revenue drop for the primary item itself. We now track the indirect effects, starting with the secondary product, Item 2. Item 2 is a complement to Item 1. These are products typically used together, such as printers and ink cartridges. According to the scenario parameters, the sales volume of Item 2 relative to Item 1 remains constant. Because they are linked, Item 2 suffers the exact same 20% drop, reducing its initial projection to 120,000 units. The unit price for Item 2, however, remains unchanged at $10. Multiplying the reduced volume of 120,000 units by the static $10 price gives us a revised revenue of $1,200,000. A price increase on a primary product acts as a downward drag on its ecosystem, artificially depressing the sales volume of its complementary goods. The final phase of the analysis addresses the third product, Item 3. Item 3 is a substitute for Item 1. It serves as an alternative version of the same product. When consumers face a higher price on the primary item, a predictable segment will migrate to purchase the cheaper substitute. The scenario specifies that this migration will increase Item 3's sales by 5%. Applying that to the baseline of 300,000 units gives us a new volume of 315,000 units. The unit price for Item 3 stays locked at $30. We multiply the 315,000 units by $30, generating a revised revenue of $9,450,000. Substitute products within the portfolio capture some of the volume lost by the primary product, acting as a partial hedge against the initial revenue drop. With the cascading effects calculated across the entire portfolio, we can synthesize the adjusted budget. We stack the adjusted revenue outputs for all 3 items, $8,800,000, $1,200,000, and $9,450,000. Adding them together provides the company's newly projected total sales revenue, $19,450,000. We compare this new figure directly against the original, pre-hike baseline of $20,500,000. Subtracting the new projected total from the baseline reveals a deficit of $1,050,000. By instituting a 10% price increase on item 1, the firm effectively reduces its net revenue by over $1 million. Increasing the price and the profit margin on a flagship product resulted in an overall loss for the organization. This inverse outcome proves why relying solely on single-variable historical trend analysis is a dangerous method for financial planning. Analysts must map out the complete matrix of product relationships before committing to sweeping financial predictions. Every pricing decision requires weighing the severe drag it will place on complementary goods against the potential sales lift generated by substitute goods. This interconnected, rigorous calculation is the true definition of a sales budget. Accurately modeling cross-elasticity is a strict requirement. It is the mandatory first step that must be solved before a master profit plan is safely finalized.